Yeah. Hope that my screen is visible. Yes. So, good morning, good afternoon, good evening, all the participants from all over the world. Today we are going to have a session on where data science meets SQL Data Warehouse. In this session, we are going to deal with Azure Synapse Analytics and Azure ML. The speaker of the day is Sabani Mati, is a VP in data science in top Fortune 500. Moving to fifth IR, who we are and what we are. We are fifth in we stands for fifth industrial revolution. We have over hundreds and thousands of strong community of technologists from all over the world. We deal with technical sessions, consultations, and real-time project on multi-cloud strategy, data science, and AI, blockchain, and extreme engineering. We also help technologists to share their learning and get opportunities through our partners Valbrite. And moving to the infography about how we are going, we have offered 240 jobs through our platform www.fuftaya.com, and we have conducted 1,000 plus sessions through our platform, and we have 363 speakers as of now associated with our platform, and we have 25,000 members associated with our platform. Roles in the organization such as head of cloud and production services, senior managing consultant, technical manager, and system analyst. She has a couple of certifications such as postgraduate diploma in machine learning and artificial intelligence, Google Cloud Platform Fundamentals, machine learning with the data, big data, big data integration and processing. You can see more about her in the given LinkedIn profile. And now, without any ado, I'm going to hand over the session to Sabarna.
Thank you so much, Gavska, for this wonderful introductions, and thank you all the participants for joining today's sessions. And with this note, I'm going to start the session, and give me a second. I'm going to share my screen, and then I'll talk about today's agenda. I just want to share the entire screen. It's not happening.
Yes, can find share option.
Share option. Windows. Earlier it was coming as everything together.
So you can share the whole screen, I think.
Yeah, that option is not coming. Coming as a window.
It will be like screen one.
Sorry?
Yeah, you
Screen
can find
one?
Yeah, screen one.
Yeah, okay. Okay. Okay.
Yeah, now it is visible.
Okay, so today's session topic is Azure Synapse Analytics and Azure Machine Learning. My name is Sarbani Maiti. I am VP Data Science working in Visa Technology. So to start with, I would like to talk about what is Azure Data Engineering and Machine Learning ecosystem. and then we'll explore some of the key services which are available in the Azure platform and how can we use them to build a ML model and predict the score or model prediction by using the SQL pool. So here is the agenda of today's session. So what is the Azure data engineering and ML ecosystem? Then we'll look at the different benefits of the Azure services. We'll explore Synapse Analytics, Azure Machine Learning. We'll run one ML model from Synapse Analytics and we'll predict from SQL. Now, this particular session will talk about Synapse Analytics and will focus on the SQL side of this entire analytics process. Now, we know that whenever we work on any ML project or we build any machine learning model, we generally work on Python and we do all the data analysis with Python. We build our model, we optimize our model, we predict score, and we deploy it in. And we can use any cloud-based system, Azure, AWS, GCP, or you can use your own on-prem data science platform as well. But in last few years, we have seen it's not only Python, and it is the SQL query is extremely important when we do such analysis. When we are working with huge amount of data and we deal with the big data or data warehouse, there we have seen that instead of using the Python data analytics, we can use the SQL query on the data warehouse, and it will enhance your query performance, and it becomes easier to deal with SQL and huge data rather than analyzing, storing, processing the entire data. Let's millions of data on the Python or Panda screen or PySpark. So a lot of time it is extremely important that we understand the SQL query as well. Second purpose is that a lot of people have come from the SQL background as a database developer background. And then they have changed the profile and get into this data science space. So for them, sometimes it becomes easier to deal with the SQL query rather than working on the Python and data analysis, all the data analysis, the concept, all the data analysis strategies, everything can be implemented with SQL query. Whatever we generally do with Python, Pandas or PySpark or any other Python data analysis language. So in this Azure ecosystem, we have seen extremely powerful data engineering and ML platform, which are coming with both the language, Python as well as SQL. And Azure data engineering will provide SQL pool in terms of dedicated SQL pool and the serverless SQL pool. We'll see that in our Azure demo as well. And using those SQL pool, we can build our model. We can do the analysis using Python notebook, but we can also integrate that ML platform with this powerful analytics platform, Synapse. So basically, we'll be working with Synapse Analytics Platform, Azure ML Studio, and at the backend, we'll be having SQL pool, and we'll be having both SQL serverless pool and dedicated SQL pool. We'll also see quickly what is Apache Spark pool, what generally we use to build some of the data analysis, or if you want to build the Spark, PySpark notebook in Synapse itself. So that way, Synapse is coming with lot of separate or lot of segregated services in one platform. So if we are using Synapse, we don't have to go and we don't have to work on different Azure services and get the output and put the input, and we don't have to do anything. We just need to integrate all the services on the Synapse platform, and we can build the pipeline quickly. So benefits, it's equivalent to all the cloud services like scalability, availability, flexibility, and high level of security, and everything is kind of managed by Azure. So that way we can build and production ready ML system. Synapse Analytics is an integrated analytics services that brings together big data and data warehousing. Synapse Analytics enables you to analyze and process big data with powerful analytics and machine learning capabilities. So whatever we are talking about. So we are getting the data, ingesting, we have to ingest the data in the pipeline. We have to store the data in the storage. and then we have to extract the data in our analytics platform. We'll analyze the data, we'll build the model, and there exactly we need the machine learning capabilities like experimentation with different models. We would like to go with different kind of algorithms. We'd like to see what is the best model in terms of the model prediction carries, like if we have to measure precision or recall, and then let's say we build multiple models, and then we select the best model, and the best model will be deployed in QA, and once it is approved in QA, then it goes to the production, and after that model will be deployed in production, and model endpoint will be exposed to the outer world through any kind of Azure service, Azure app or Power BI. We can build an extremely powerful predictive analytics platform. So everything is built on one platform, that is Synapse, and we can build this entire pipeline with all other services. So let's look at the data ingestions. So the Synapse Analytics enables us to ingest the data from various sources. So its sources can be other database like SQL Server or Oracle. Even it can be the AWS RDS or Redshift, which is completely sitting in a different cloud environment, or it can be coming from on-prem data. Let's say you have a huge database in your on-prem and you want to ingest the data to the cloud platform, and it can be coming from different data providers or external data providers, and a lot of time we extract the data by using the web services or different API services. So data, these are the different sources of the data, and then type of the data can be anything like structured data, unstructured data. Unstructured data, we can talk about text data, video data, text, then audio data. So data can be coming in any form from anywhere, and then we have to store the data, and then we are talking about data storage. And in Azure, we have the Azure Blob Storage, Azure Data Lake Storage, and SQL Server. And we can store the data any of this. You can also ingest the data from other cloud services, as I said, AWS S3, SQL, Google Cloud, or any other platform. Then once we store the data, we need to focus on the data preparation. So in terms of cleanup, deriving the new columns, or we can prepare the data, we can play with the different columns. Actual feature engineering is also done at this particular stage. We can also apply a lot of transformation logic at the column level as well. So all these kind of data preparations can be done in Synapse Analytics platform with the varieties of tools like data cleaning, data normalization, data transformations, and it can be done in a Azure Auto ML platform as well, because all will be integrated together. Now, in the analytics side, we have the data warehousing capabilities. Data warehousing means when we are getting data from different sources, we are storing the data in one data lake. Data lake is kind of data. We can store the any type of data, structure, unstructured, and we can just throw it in the data lake. Everything will be stored in the data lake, but it needs to be managed. It needs to be stored. All the data must be stored in a secure place. So it must be accessed by the people who are supposed to access. All other data privacy, data security must be maintained at this point, because most of the time all the data analytics platform or machine learning platform, to be specific, they use the production data. Even if we are building the model in the development, we need the production data, and that point of time organizations are struggling to manage the security compliances for that particular data set, because in normal software engineer, when we develop any application, we generally do not need the production data when we are developing any POC. But in our case, in data science, we want to start our modeling or POC with the sample of the production data. So it is extremely important that we encrypt all the PHI information like personal identification informations, name, email, phone number, zip code, and SSN number and all. Everything must be encrypted. So security zone is created once data is landed in the landing zone, and then it goes to the final data warehouse. And Synapse also kind of provide a lot of big data processing capabilities. We'll see that. And Azure Machine Learning. So what is Azure Machine Learning? Azure Machine Learning is another services which is offered by Azure. So Azure ML Studio is a extremely powerful advanced ML platform. So here we are only focusing on the ML side, like whatever we need to build and end-to-end machine learning model, all that kind of services are provided here. As I said, when we develop the model, we need the experiment environment where we can experiment with varieties of algorithm, we can experiment with varieties of data sample, we can experiment and build different versions of model. And all the model artifacts must be stored or registered in the system, because let's say there are three or four different, three data scientists are working. One data scientist has got the best result with model version 3, model 3 and data 1. Another data scientist has got data 2 and model 3. Another one has got data 4 and model 1. So at the end, all three models will be compared and best result will be selected. And then we need to go back to that particular version of the data and model. So if we keep everything in our own local system, that's literally a nightmare, because we can't even track which model is using which data sample or which data version. And even we also store the model output, like once model is evaluated, the best score. Sometimes some people would say this precision and recall combination will be good for that particular use case, but some people might say no, in our case this particular precision and recall will work. So you may need to deploy multiple models version in multiple endpoint which are exposed to different kind of stakeholder. So all this model registry, model versioning, model artifacts, everything are safely stored in the Azure ML Studio platform. And experiment, and from experiment to QA to production deployment can be done easily on the ML Studio. So I think I have already talked about all of them. Like it's a advanced platform. It has it also have both the features. The Python SDK versions are available, so we can install the Python SDK version and we can use Azure ML libraries and we can build our entire model using the ML notebook. And we can also use the Azure Auto ML, where you don't have to code. You can just drag and drop. It's a designer studio. You can drag and drop different components and then you can build the pipeline and you can build the prediction model. But today I will show you the notebook versions where we have the Python SDK code which is written. And then Azure ML Studio also offer a lot of different ML framework. Like if in Python you scikit-learn, in TensorFlow or Venx, then and all the known and popular ML network frameworks are available in Azure ML Studio. It has also R language. R is also available on this particular studio, but yeah, we'll be using Python only. Okay. And then running an ML model from Synapse. So what does it mean? Here, what are you going to do? So we are going to build a model in Azure ML Studio, and that particular ML Studio will be linked with the Synapse. The Synapse platform will be used to get the model prediction data, like test data. So every model is built and it gives some kind of prediction by using this predictive model. Once it is deployed, we test unknown data. And then again, we predict by using the model. So at the end, we get some kind of prediction on the unknown data set by using the model. In Synapse Analytics, we'll be using that test data. We'll use the model which will be built on the Azure ML Studio and will analyze the prediction model by using the SQL data. So here we'll be integrating all the components and then we'll see how the predicted output will be stored in a SQL database, and then you can run your known and popular SQL queries and you can create your own data set and then you can build a Power BI, a visual. So Power BI is not part of today's sessions, but once everything is stored in the SQL database, it can be easily integrated with the Power BI application and you can also visually see all the predictive analytics result. We can also see the graphs and visualizations are also available on the Synapse. We'll see that. You don't have to directly go to Power BI at this moment. Okay. Now predict from SQL. So as I said, with an Synapse Analytics, we'll create a SQL pool. Now we'll see what all the SQL pool and how it is connected to Synapse and all. So this is the high level Synapse architecture. On the left hand side, again, all the different sources you can see. Data can be coming from on-prem, cloud, SaaS data, streaming data. They will be ingested in this Synapse Analytics platform. In this analytics platform, we will log into the studio, Synapse Analytics Studio, where we'll get all the features, data integration, management, monitoring, and security. Then this particular Analytics Studio will be integrated with the Azure ML platform, Azure Machine Learning Studio, by using the link service. And then we can use all the analytics runtime. Like within the Synapse Analytics, we have runtime. One is the SQL runtime that can be serverless and dedicated. Serverless means whenever we need that particular SQL pool, we'll turn it on and we'll use it. Once we are done, we can close it. So that way it's a pay per use. So I will pay for that particular SQL pool if I so for whatever time I'll be using that. So if it is for 1 hour, let's say my SQL pool is running for this demo. So right now probably for 2 hours I have to pay for that. Then dedicated. So I have also created a dedicated SQL pool. I'll show you. So dedicated is dedicated, correct? Even if I'm not using, I can delete it. If I delete, all the resources will be deleted. So dedicated SQL pool, it's kind of running all the time. Everything, it's kind of a database. You can think about if you install a SQL server on your local database or on your office on-prem database, it's a kind of fixed server which will be running 24/7. Even if on weekend we are not working, it's there for you. But it's like once you buy it, it's yours. You don't have to think about it. Okay, then I am using it for my usage is going high or so, because it's already there. So depending on the use case, we need to decide whether we should go for the serverless or we have to go for the dedicated SQL pool, because that extremely that is actually dependent on the use case and SLA. And so if my server is 10-20% or 30% utilized in a week, then definitely I should go for SQL serverless. But if it is mostly 90% time, 24/7 kind of applications are running on the particular SQL pool, then probably it's good to have a dedicated pool, and probably that way I can bring the cost a bit down. Apache Spark is another runtime is provided by Synapse, where we can build our notebook. You can build your even you can build your model here, Apache Spark as well. Then Data Explorer is used to explore the data. Kind of you can analyze the data with some no code versions, and you can also build in some of the libraries are also available. Today I'll be using SQL and I'll show you Apache Spark, but mostly I'll be working on the SQL side. The last one is the data lake storage, where we'll store all of our data. So it can be our input file, which will be ingested here in the data lake storage Gen2 storage account, and our model will get the data from this particular location. It will process the data, it will prepare the data, it will analyze, then it will build the model. Once model is built, model predictive output and test data will be stored here as well. SQL will pick the data from here, then it will create its own database here. The database will also create the test file from this storage account. And at it, you can have your Power BI account, and once it is activated, you can create a nice dashboard with all the predictive analytics output. Okay, so Synapse Workspace. So let me now directly go to my Azure space. Let me know if it is not visible. I'm on my Azure site.
Yeah, it is visible.
Okay,
So
great. Okay, great. So for Azure, I'll just show you how to log in. So this is the Azure ML Studio. So once for that, you need an Azure portal. Now you need an Azure app subscription. If you have a free tier, you can use that. Or if it is not available, then you have to convert it to pay per use model. That means whatever services you'll be using, you have to pay for that. These all services are paid services. They are not free. And so here you can see Azure ML. So if I go to the home, I'll show you how did I come here. So you can see all the resources and all. So generally, all the resources what I have created coming under this resources and recent tab. And first, I'll open the Azure ML Studio here. So this is the Azure ML Studio. Once you come to the Azure ML Studio, you will see this studio link. So you have to create the Azure ML Studio. So you can follow the link. There are nice documents that are available. It's very simple. You have to just go give it a name, attach the subscription ID, and then you can just hit it. It should be created. So once the studio is created, I have to launch the studio. Why I'm opening it? I'm opening this because I want to create my model here. So once I'll come here, let's look at all the different services which are available. So this is the home. Then this is notebook. So entire pipeline. So if we look at the entire, you can think about this ML Studio as a pipeline. So all the pipeline components will be available on the left hand side panel. So you can see it here. So notebook. So in notebooks, you can create your own notebook and you can start coding, create notebook, or you can upload file. So here I have uploaded a model here. So this model is what it is doing. I'll talk about it. So this is a New York taxi services data. You must have seen it. It's very known and popular data set available publicly. This particular data set has various kind of data which is related to New York taxi services. So they travel from one point to another point, how much tips generally they do provide, what is the taxi fare, what is the duration, what is the time of travel, what is the end time of the travel. So that way you can actually create multiple model. You can predict what is the fare of a particular day, of a particular time, of a particular trip. So here we are going to predict the tips. So for a particular trip, what will be the tips by looking at all other attributes or features for that particular data set. Now this model is already built and you can also use any model. But you have to think about, we have to be careful about few prerequisites. That's what I'm going to talk about. So one thing is that in Azure ML, all these models must be using the scikit-learn ML package, and it should use the ML table. The model and the data format must be ML table. I'll show you the details of this model in a minute. So let's look at this model, how it is. The notebook is simple notebook. It's similar to our Jupyter notebook, what generally we use in our local environment. There is no difference. Only thing, this particular notebook is hosted here in the Azure. It's a Azure cloud. It's hosted. It's running on the Azure. Now, notebook cannot be running like this. So to run the notebook, you need a compute instance. Correct. So notebook is just a notebook. It doesn't run. It doesn't do anything. You can just write the code, but to run it, you have to create a compute instance. How to create a compute? So you have to create on the left hand side panel here. You can see compute. We'll go there. I have already created a compute instance for running this demo. But here, if you want to create a new compute, you can go there, new, and generally select the lowest one. So I just created a small machine, and then I hit the create button, and it will take a few minutes, and the particular instance will be created. So I don't need it because I have already created one. I don't want to do this. Right? That must be cancelled. So once it is created, it will look like this. So the instance will tell me it is running state. And this particular instance, now I can open that notebook from here as well. Here also you can have a direct link, Jupyter Lab, Jupyter, VS Code. If you are comfortable with the VS Code, you can do that as well. Then you can also go to the terminal where you can create your own environment and you can create the virtual space, everything. And here is the notebook. So right now I'm on the notebook side. It's already open it here. So if I go there, so this particular notebook is running here, you can see I have also run this because it takes time to run. So you can see some of the libraries we should be extremely careful. One is that we have installed this particular Wenix framework. The model is running on scikit-learn and Wenix framework. And these are the list. You can see requirement text file. You can create your own requirement text file and you can also run it. Now you can see there are a lot of Azure ML libraries are running. Let's look at them. So these are Azure Storage, Azure Blob, all the pip install are already there. Now, here this open dataset, taxi dataset is already available in Azure ML open dataset. In Azure ML open dataset, Azure has provided a lot of open datasets, similar to scikit-learn. Even we have seen most of the libraries, they do provide a lot of open dataset to test the library, to test the sample quickly and easily. So we have just imported that and then we have used it. And here what we are doing, here we are actually extracting the data and converting that to the Panda data frame. And after that, once it is converted to Panda, then it's you can run your simple Panda format and simple Panda related any kind of Python data analysis, libraries, data analysis, command, everything to process the data. So these are the basic ML model. I'm not going to talk about the ML details here. It's a different topic altogether, but the basic model building is done. This is the train test split where we have, it is a 70%, 30% split is done. And then the model is split into it. After that, we have created a test data. Now here we have saved the test data in this CSV format. So when we split the data, the X train and Y train will be used for the model training. But here we are also kind of extracting the test data set, which is kind of X test and Y test in the local database. So here right now, once you create two CSV, it will be saved here in this Azure notebook. But after that, I downloaded that in my local and then I uploaded the same test file in the Azure storage account so that I can use it in the signups. I'll show it. But here is the model specific stuff. And I'm not going through this. These are the libraries you can see which are used, scikit-learn libraries. And here, convert the model to Wenix format. Now here the model is converted to Wenix format and then it is registered in the Azure ML Studio. Now here for registering the ML model, we have used the ML flow. So ML flow, you can see this is the Azure ML core. This is the core Azure ML library. And then this particular workspace will be used, which I have created with my resource group, like responsible, I think this is Azure responsible RG resource group. So yeah, here is this Azure responsible ML studio name. This is the Azure ML resource group. This is the region and this is my account name and other details. Now ML flow ONX is used because that way model will be registered in the Azure ML Studio model registry. Now where is this? So for that you can go to this model. This is the model registry screen where all the models can be registered by using the registry model code. And you can see this one is my latest model. If I click on this model, once the model is fit and built, then the model is registered. Now you can see all the versions and model details are tracked here in this particular registry. So if I think this particular version is not good or result is not good, I want to create another version with some other algorithm technique. I can do that. Then another version. So another row will be created. So literally, if I create 3 different versions, 3 different rows will be created under this model. So this model registry is extremely helpful when we want to track a previous versions or any versions of the model. You can see this. This is created today and this is the version. Now, a couple of things you can see. The type of the model, you can see the flavors. Python function flavor is Wenix. So first we created a scikit-learn model and then scikit-learn model has been converted to Wenix framework or Wenix model. And then this is the ML flow model. You can see. So the type of the model is ML flow. This is also important. Then it's Azure storage and all. After that, we don't need so many stuff. Now, what it does, generally it creates different jobs. So I can see once you run this model, in the Azure ML Studio, it will trigger the jobs. So once it is created, everything will be tracked here in the jobs. So here, jobs. So this is the taxi predict experiment jobs. So this job was created today. And this is completed. And what is the output of this job? This job has created this particular model, which is now registered under the model registry. So this part is done here. So we have created a model. We have registered the model in the model registry for further use. And we have also downloaded the test data. This test data, which will be used as an unknown data set and which will be used in the sign up side. Now let's go back to the sign ups. What is happening here? So this is here is my sign ups part. So if I go there, so this is the, you can see this is the sign ups workspace. I have created a sign ups workspace. So Azure sign ups analytics, you can create your new sign ups analytics screen. If you go there, so like you can see the subscription, it is asking for which resource group. I have several resource group. I am using this one. You can create your own resource group and then here workspace name, give it. So basic information, not much. And then if you hit the review and create, it will be created. So again, I have already created one. So I'm not creating it again here. So this one I have created for this demo purpose. So once it is coming here, I'll go to the Azure Open Studio. So once Azure signups analytics screen will come, then it will give you this sign up studio. So I'll click on this. So now sign up studio is coming up. So it is asked for the authentication again. Okay, so it's here now. Now look at it. On the left, you can see directly. So ingest, explore, and visualize. That's the basic offerings. Now here you can see the data. So in the data side, what are the data you can see? If you go here, in the linked site, you can see an Azure Data Lake Storage Zen 2. So this will be automatically created once we'll create the Synapse Analytics platform. So once I'll create my studio, it will by default, it will give it a Azure Data Lake Storage Zen 2 storage platform. And with that, it will ask you to give some name of your storage account. So I created a storage account with this name, Sarbani Synapse Demo, and then I created one file system. So everything will be coming when we generally create the Synapse Analytics platform. So if we click out here, so in this file system, I have stored all my data which are used for this particular demo and project. So here you can see the test data.csv, what we have created in the Azure ML platform. That is, I don't want to just download it. So I have uploaded that. So first I download from Azure ML Studio and then I upload it here. So you can upload it here, correct? You can upload anything in the storage. Now then, once it is created, now let's go to the other part. So this is the storage part. Now we look at the develop. So in the develop side, you can see a couple of things I have created. SQL script. So let's look at a couple of SQL script and how are we going to use the SQL server and SQL script with this. So here we have seen already I have one demo for, there is another file I created here. So a couple of Sparks pools and all are created. These are created by the system. It's not nothing to do with this. Now let's look at this one. Another is the manage. So this is, I'll look at the set. So in the manage side, you can see all the different services what we are working. In signups, you will see 3 different analytics pool. SQL pool, Apache Spark, Data Explorer. In SQL pool, we have 2 different pool built in, which is serverless pool. This particular pool will be created by default when we create the Synapse Analytics platform. So we don't have to create it. It is already there. We just need to go there and we need to turn it on. By default, it is switched off. And once we come here, first time if you come here, it is a blank screen. And then you can see the refresh, the built-in will come here and then you can switch it on. It's an auto. You can see it's an auto because it is created by the system. This one I have created. So this is a dedicated SQL pool. And for that, you can also create it from here. Like here, you can see a dedicated SQL pool name. So I can create a demo one and you can see the price, correct? It's quite costly here, 1185, almost 2000 per hour, but I can reduce that cost by this. So by default, it keeps the resource infrastructure somewhere here, but we don't need all this thing for a small demo. So generally, I created the dedicated pool with this infrastructure. I then hit the create, it created that. I'm not going to do this again. So I have already created this dedicated. So this is serverless, this is dedicated. Now, in this episode, this two, you can think about your data. So these are the SQL Connect which are available. These are the SQL Connect with signups. So far we are talking about Python, but now here exactly we have landed in the SQL server where you can run your SQL queries, you can create your database, you can create the schema, you can run our analytics query and all. Now Apache Spark Pool, Spark's pool is a similar kind of runtime pools where you can create the different kind of notebook. So this is connected here in the develop section. When we create a notebook, I need a runtime to run the notebook. Similar way in Azure ML, we need a runtime compute when we run a notebook. In the develop side, when we are creating another Apache Spark notebook, I need a Apache Spark pool or runtime which will support that notebook to run. So this is created here. Now, if I go there in the develop section, there is a notebook. So let me open that and you can see it is running on this Spark pool. Correct? So this is actually a PySpark notebook. This is not a Panda notebook, but for that you have to convert it some of the stuff because by default it is a PySpark code. So this code you can see Azure ML, it is connected to the Azure ML and it is importing the similar data set. What it is doing, it is simply downloading the data set and reading it and showing it in a data frame format. I just put a simple demo because I'm not working with this Spark pool at this moment. So just to show how it is connected to the Spark pool, you can launch the notebook here. You can attach with the any of the Spark pool. Right now I have only one Spark pool. So by default it is connected there and I can run it. I can hit it and it will run like a normal notebook and it will extract the data from the Azure ML. Now see, it is already connected to Azure ML. I have not done, I just used all the Azure ML libraries. And then it will extract for the New York data for a particular year, 2018. And I have used only 1 month data because it's a huge database, huge data set. I don't want to use that for my small, little tiny Spark pool. Then it may give you the runtime error. And then it is now a Spark data frame. It is created a Spark data frame and it will show you the data set one it is running. It's a bit slow because it's a small Spark machine. Now that's all I have done here. Now let's focus on the SQL side. Now in SQL side, so you can see now there is a small how to create all the SQL script. There is a plus sign I can create on it and I can create my SQL script. I can create my notebook. I can create my data flow. But right now I'm just creating a SQL script. And then in the SQL script, what I'm doing here, I'm creating a database, data exploration DB, and an external data set. So what exactly I'm doing here? So all the data lake, this particular data locations, external data source, this one. So here from this external data source, I am creating a table here. So it will create an external data source named console lake, where in this particular storage. And this data set where where it is going to available. So if you click on the data, data workspace. Yeah, so here I have linked it with the storage account, and in the workspace, this particular data and everything will be available in the storage in the workspace. Here you can see this data exploration DB is created under SQL database. Sorry, this one. So these are all external table. This is a simple database. I have not done anything. Now let's see what all is there. I'll again go back to my SQL part. And here you can see this is a create table. This is another create exploration DB. This one was not good. And then second, select top. Now I can also select whatever is there in that particular data set. Now I have used another Parquet file. So this is a data. First of all, an external database is created here in that particular data set worksheet. And in my data storage bunny file system, there is another file I used, New York trip. It's a small Parquet file. The same data set, I have created another small sample, which is residing here. It's again in the data and in the link section. If you go to the file, this one. This Parquet file. And if I go to the workspace, this Parquet file is now converted to this external data set. And I can also query it by using this SQL query. So here I'll go there, top, select top. So if I come here and execute, look here, it is automatically connected to the built-in. Built-in is my serverless SQL pool. So it is this particular query is right now running on serverless SQL pool, where I have already created one external database from my storage account, and this particular Parquet file data is stored there. And this is the syntax. So open row said, and this particular link will be available here. Right click, and I can see the properties. So each file will give you will give the where this is the URL. This is the way, this is the access, this is the way we can access that particular file. And then again, let me go back to my select top and all top 10 result. Now, as you see, it's a top 10. You can write any other query. Let's take another example here. So this is another query, a bit, I just put a few logic here, like passenger count, sum of trip distance, average of trip distance. So it will give me a order by, so it will group the record using the passenger count, and it will give their total trip distance and average trip distance for each count. So let's run it. Okay, so you can see it is running on master database. It is using the same, you can also check whether it is running on a serverless or dedicated pool. It's running on serverless pool. It is using the same Parquet file, which is stored in my storage. So I am querying the Azure data storage or storage, blob storage or storage file, stored file, using a query which is running on serverless SQL pool. And it is also using this. This pool will need a default or temporary master database. So that is that external database is created because anyway it's a SQL query, correct? It will be running on some database. So that particular temporary database we have to create, that is created with that particular create external table, and then virtually it's kind of running on a database, but actually it is querying the data which is stored in your data store, which is linked to your storage account. So this is the way it works. It seems to be complicated, but yeah, that's the way it works. So eventually you can run any kind of SQL query to analyze your data which is stored in your storage account. So if you are comfortable in SQL query, you don't want to right now, you don't want to touch the Python, I mean very complex Python query, but you are extremely good in SQL query, you can use this entire SQL setup or SQL pool to query any data in storage account. Now this is one part of one offering of this SQL database. Now we'll move on to another way where we have stored that particular data. You remember we stored that test data and in the storage account. Now we want to use a dedicated SQL pool to predict the data from that particular storage. How to do that now? So for that, let me just close this queries now. Okay. Now let's move on to this one. So what happens here? So once we used the model and we did the prediction, everything is stored in the Azure ML. But it is Synapse, correct? So I have the query in Synapse and all, but how to integrate, because whenever I am using my test data as unknown data, I have to call the Azure ML model to predict. So that connection is done through a link service. So this link service is created here. If I go to the manage and then click on the link service, then I have to create a link service here. So new, I can show Azure ML, this one. So link service is an critical component here in Azure, entire Azure. So let's say we are working on Azure Data Factory, or we are working on Azure Data Flow, we are working on Azure Synapse, and various components are connected to one pipeline by using the link service. So Azure ML will be connected to Azure Synapse Analytics by using the link service. So I am right now, I am in this Azure Synapse platform. So I am in Synapse platform, and I am calling, or I'm using Azure Machine Learning from link service. So I'm creating a link service to Azure ML, then continue. Then let's say ML service 2. And then you can see these are all default will come here. Then from Azure subscription, this is my pay as you go subscription. Then workspace name, I'm using the same workspace where I'm going to create another link service. And then you can see managed identity, and this is important, managed identity name, which I have created here. Now, another important thing, this would not work. If you're doing it for the first time, it would not work, it will fail. So this is the test connection. Generally, we click on the test connection, it will tell you whether the connection is successful or not. Here it is successful because I have already created a IAM role on Azure ML, so that Azure ML and Azure ML is giving access or giving permission to Synapse to access all the models which are built in Azure ML. How did they do that? So that is done through a IAM role. That is done. So now it is done. 1 second. Just cancel it. Once it is coming back. Yeah, so then here, it's already created, so it's not showing me here. I think I'll just check it later. So it's not coming up here directly because it's already created the link services. So, but yeah, so once you create the Azure ML Studio, then at that point of time, we can give that particular IAM role access to that Synapse. So you have to just create a new member and it will be coming there. Now, once it is done, that this link service is important. If this link service is created, now I can go back to my Synapse platform, and here you can see that model scoring one. This is a model scoring. First, I'll create a table. So this particular query, you can see this is creating a NYC taxi table in dedicated pool. How it is dedicated pool? Again, Bani SQL pool. This is my dedicated DED. This is my dedicated pool. In this particular dedicated SQL pool, I'm going to create a table where I'm going to store this only these columns, because for prediction, I don't need all 100 or 200 columns. I need just few important columns where I will check whether it is tipped or not. So the prediction model will predict 1 or 0. 1 means tipped, given, or 0 means there is no tip. given. And it is coming with this particular features like fair amount, payment type. So basically it is a prediction table. It's not an actual data table. And then these are the syntax will be used. Then this is copy into NYC taxi. So the copy command will be using here to copy the data into this. And with this file, type this, and these are the syntax. Now, also I'm doing a select top 100 star from NYC taxi. Now I can't, this is already created. So I don't want to, I can do this as well actually. I don't want to run it again because it will give me error. Now, once this is created, I'll show you the table directly. Table. Here you can go to the table. Now this is the Bunny pool dedicated. So this is my dedicated SQL pool. And here this particular table will be created. So DBO NYC taxi is created here. Now I can also query this directly. So right click, select top 100s. So this is similar to database. Now you can visualize this as your normal SQL Server database, correct? When you work on the SQL Server, you have a left-hand side, our tables, our schema, our views, all the store proc, everything. And I can right click and we can run direct query. Now you can see top 100 queries. You can see tip. Now this is coming from where actually? Now this was not there initially, correct? This was, it will first load the test. This particular column would not be there. Now you can see this is the ML models. There is another query which is created here. So this particular model is created, not created, this particular model is taken from Azure ML and predicted on this data. Then only this particular prediction or predicted values are appearing on the screen. And this is done through this scoring SQL. First table is created, prediction table is created here. Then there is another SQL query which is created, which will create a store procedure. Store proc, what it is going to do, look at this. This is taking the input data. It will select couple of tables from this table. And then look at this. From predict, select star from predict. Now here, this is a built-in model prediction features available in SQL dedicated pool, which can be used along with one Azure ML model by using the link service, so that this particular test data, which is available in DBO, this is a NYC taxi database, and the model will predict the actual target value. So here model, it is saying select model. Now model is coming from the parameter, where it's coming from directly from the Azure ML, the model what we have already registered. The same model from NYC AML models table. Look here, so model is registered here. The moment we will run this AML models. And how does it run actually? So any table which is created here, you can right click and machine learning predict with a model. So if I have a data set which is coming from the same training data, I mean similar structure, everything is similar. So I can apply any model on this particular test data. It's actually test table. It's not a file. On the test table, I can apply any model and I can predict the output through the target value. So you can see here, it is telling me which, here exactly you can see the benefit of linking Azure ML Studio. So it will directly open the Azure ML workspace where I can select my ML Studio workspace, what I have linked through the link service, correct? This is link service, Azure ML service one that I was creating. Now this is created here. With this link service, it is giving me access to that particular model, which was created long back. I mean, long back means in today, I mean, somewhere India time around 2 p.m., 2 or 3 p.m. This particular model was created and now I can use this model. I can continue and this particular model will use this particular data inside this NY taxi table and it will create the prediction which will be finally stored here. That's it. So now my prediction is done, but not on any Python notebook. I have predicted the model output using some unknown data set, but using the SQL dedicated pool, which is there on the Synapse Analytics. So this is the way you can actually all SQL queries, you can utilize your SQL capabilities and SQL skill to predict any data set on Synapse Analytics. And once this is done, it can be easily integrated with, actually chart. You can also create chart. And we can create anything here. You can use any columns. So some lot of chart and visualizations you can directly perform on this particular Synapse Analytics screen, but you can also integrate that with the Power BI, through which you can expose that BI to the business users or other stakeholder who doesn't know anything about all these backend hassles and complications. They just need to see, oh, this is the predictions. Okay, I want to see in which area the taxi drivers are getting the maximum amount of predictions, maximum amount of tips. So you just need to see maximum one in a particular area. So all this kind of analysis you can do with your SQL query, because now your prediction is available here in this particular database, NYC taxi. And this will be residing here. So model is done. You don't have to run the model again and again. Everything is done once. All the data will be stored here. Now you do all your analysis with this data set. You can run your SQL query, complex query, group by, order by, and you can integrate that with Power BI. So with this note, I can end the session today. I think I'm done. And now I am open for any questions.
Yeah, participants, you can unmute yourself and you can ask the questions. Yeah, few questions in the chat.
Sorry, how? Okay, I have to check that.
Let's another question is.
I have to. I'm not able to see the chat.
Yeah, difference between group by and order by class. Can you please explain the group by and order by usages and their differences?
Okay, they are all normal SQL queries. Anything, any command, whichever is used here, they have nothing to do with Azure Synapse or Azure Analytics. They are all group by and SQL. So group by, if you want to group by as I did that, you have to group by the passenger count and for a particular region, and you want to group by the passenger count, but one passenger may travel multiple times. Every time the passenger is giving fare. So you have to add all the amount. So once you group by all the same passengers, multiple trips, you have to deal with all those, all those numerical values of the sum. So either you can have sum of all the trips or you can have average of all the trips. And then you can group by for a particular passenger, and that is used frequently in SQL. And order by is you have to just order by, like first you group by the count and then order by count. So maximum amount of so the passenger who has traveled the most will be coming on top. So order by ascending or descending. So if you just do the descending, so ascending will be maximum count will be on top. But that count is passenger count on which number of trips. So that way. So these are all SQL queries. So for that, you have to learn the SQL query. So that has nothing to do with this. In today's sessions, I have not talked about anything about SQL queries. So all the queries what I have used, they are, so assumption was that, you have to learn SQL queries separately. You have to learn the Python query separately, Python language separately. And then you can use all this infrastructure where you just, apply all the languages and you can build your pipeline, you can build your model, build your analytics and all. Anything else?
Yeah, one more question is there. From the SQL example discussed, can you please explain the part from dbo.nyc_taxi instead of using from table name?
Yeah, so DBO is the schema. It's a
schema,
owner. Yeah, it's the owner of this particular table. So general rule, good practice is that we generally write dbo.nyc is the table. This table is created by the DBO owner, because I am the owner of this entire account. So everything is created by admin access or administrative or DBO access.
Yes, it's a default schema,
Yes, it's a default schema. Yeah, it's a default schema.
So participants, any more questions? You can unmute yourself and you can ask.
I have one question here. The private endpoints you were talking about while creating the link service, right?
Mm-hmm.
What was that?
So during the link service, one second.
Private endpoints.
Endpoint. So no, we have not used the endpoint. I've used just 1 second. Yeah. So in the link service, so let's say you are creating a, let's say this one. Yeah. So which one?
Somewhere I saw that private the link services you have chosen the private endpoints, right?
Here.
I think it was there in the ML Studio.
ML Studio.
Scroll down on the left panel. Scroll down. That link services is given. Click that.
No, this one I have not used. No, link service was created from Synapse. Link service was created from Synapse Analytics platform and it was linked to Azure.
Okay.
Azure I have not created. Link service was created on Synapse side.
Suppose if I want to connect some SQL, all right. So if I am creating the link services, how do I connect those servers? For example, if they are in the same network, if they are not in the different network, then how do we access securely?
No, SQL. I'm sorry. What do you want to connect?
See, link services, we have to connect with the different SQL server. Okay.
Yeah, anything. Link services is there. You can connect to Data Factory. You can connect to SQL Server. You can connect to
Let's
any
say,
other.
let's say any kind of services. Let's say any kind
Yeah,
of
any
services.
service. Right.
Okay. If that services, if they are not in our network, for example, in our VNet, different VNet it was there. So
So everything
if you
will
want
be.
to connect,
Yeah, they all need to be mentioned in the when you are creating the link service, private network, or it's going through the virtual your VPC connection. Then you have to create the. You have to talk to your admin person.
yeah,
Definitely,
now
you
in
will
the
be
left side,
creating
if you
security
see that
groups. Mm-hmm.
in the left side, if you see that was a disabled, right? The managed private endpoints below the credentials, the security under security.
Which one? Synapse or Azure ML?
In the current page,
Huh?
check in the security under the credential, the managed private endpoint was disabled, right?
Security here.
Security, the last one.
Okay, this one, because I have not created with all this industry or productionized security controls here. It just everything is open in my system right now for the demo.
Okay.
So security has a very complicated setup, and sometimes it because generally if you are working in your organizations, even it's not so simple. Organization will give you a particular IM role. You will get a security group or resource group within which you will create everything. So everything will be controlled by the resource group. So you will only work on your resource group. You will not be able to see anything else. There might be 100 people are working on the same Azure account. So I'll be only working on my resource group. And within resource group, you have your own team and they will be having different contributor role or developer role. So that's a separate topic altogether. How to manage IAM access security is it's a very different topic, and it's not a very simple. There are so many things to understand. Currently it's open. Currently it's just I just use the I'm the owner of this entire account, so it becomes easier, I would say. But in organization account, in the production account, when there will be different people who will be managing the account, you will not get access to all of them at all.
Okay, another question is the data explorer tools.
Data Explorer pool, it was not part of this today's session. I have not touched it.
Okay.
Yeah.
Okay, good. That's all.
Okay. So that's any more Q&As? So I think we can go to the certification desk. Okay, just I will share the screen. First I will. Yeah. Participants, the speaker code for downloading the certificate is JO29IT. So I have shared this in the chat. Again, I will share it. So just I will explain the procedure to download the certificate. Yeah, already I have shared the link for downloading the certificate. Just you can use the link. Now you can register as a guest, or you can myself. No, I have registered over here, so I can navigate now. I can click navigate now. So now you see, you can find here. For myself, I already downloaded the certificate, so it is coming like this. No, download certificate. For your it will be coming as claim certificate. Now you can click that, and you can provide the secret code. It will ask for the secret code, and you can download the certificate. So that's all from certification desk. I hope that you may all enjoyed the session, and we got an end-to-end idea on how to work with Synapse Analytics, how to work with Azure ML, and how to work with SQL. In short, we got a brief introduction. So I hope that we have enjoyed the session. And once again, on behalf of multi-cloud for you, I'd like to thank Sarbani for providing a wonderful session on Azure Synapse Analytics and ML. It's a great session. Thank you.
Thank you.